Download this code from codegive.com, link in the description below. Removing circular redirect issues with Flurl, issue 714, tmenier Flurl. This tutorial will delve deep into the Remove Circular Redirect Detect issue, issue 714, in the tmenier Flurl library, explain the problem it addresses, and provide a comprehensive guide with code examples on how to resolve circular redirect scenarios when using Flurl. Understanding the problem, circular redirects. A circular redirect occurs when a request leads to an infinite loop of redirections. Imagine the following. 1. You request URL_A. 2. URL_A redirects you to URL_B. 3. URL_B redirects you back to URL_A. Your HTTP client would endlessly follow these redirects, eventually hitting a limit and throwing an exception, often resembling. Too many redirects detected. Exceeded maximum redirect count. Circular redirect detected. The Flurl library, like most HTTP clients, has mechanisms to prevent these infinite loops. However, issue 714 highlights scenarios where the default circular redirect detection might not be robust enough, or where the default limit on redirects is insufficient. Issue 714, tmenier Flurl. Why it matters. While Flurl does have built-in redirect handling, issue 714 underscores the following points. Default redirect limit. The default maximum number of redirects allowed by Flurl might be too low for some applications. Some web servers or APIs intentionally use a higher number of redirects as part of their design. Complex redirect paths. Real-world redirect paths can be more intricate than a simple A-B loop. They might involve multiple URLs and specific conditions that cause a circular pattern after several hops. Custom logic and control. Users sometimes need more granular control over redirect behavior than what Flurl offers by default. They may want to log redirects, inspect redirect URLs, or apply custom criteria to determine if a redirect is part of a circular pattern. Potential vulnerabilities. Circular redirects can be exploited as a denial of service (DOS) attack if an attacker can manipulate a server to create an infinite redirect loop. Solutions and techniques for handling circular redirects with Flurl. Here are several strategies to address circular redirect issues when using Flurl, ranging from simple configuration adjustments to custom handlers. 1. Increasing the maximum redirects allowed, simplest approach. The easiest way to address a too many redirects error is to simply increase the maximum number of redirects that Flurl is allowed to follow. This is done via the max redirects property on Flurl client or via extensions on iFlurl request. Explanation. With client, new Flurl client, with settings, s=s.max redirects 10, this creates a new Flurl client, configures its max redirects property within Flurl client settings to 10, and applies it to the request. With max redirects 10, this is a Flurl extension method that provides a more concise way to set max redirects directly on the iFlurl request. Flurl client settings. Max redirects. This property controls the maximum number of redirects that Flurl will follow before throwing an exception. The default value is usually around 5 or 10, but you can increase it to a suitable value for your scenario. When to use *, this is the first approach you should try if you are getting too many redirects errors. It is the simplest solution for cases where the default redirect limit is insufficient but the redirects are, in fact, not circular. 2. Intercepting and inspecting redirects, custom redirect handler. For more complex scenarios or when you need more control, you can create a custom redirect handler. This allows you to inspect each redirect URL and potentially stop the redirect chain if you detect a circular pattern. Explanation asterisk. Asterisk I redirect handler asterisk this interface is the key. It defines two methods, should redirect async and before redirect async. Asterisk should redirect async asterisk this method is called before each redirect. It receives the iFlurl request and iFlurl response objects. It should return true if the redirect should be followed and false if the redirect should be stopped. This is where you implement your custom circular redirect detection logic. Asterisk before redirect async asterisk this method is called immediately before the redirect happens, after should redirect async has returned true. This gives you a chance to modify the request, example add headers, change the URL, before it is sent. Asterisk underscore redirected URLs asterisk this hash set is used to track the URLs that have already been visited during the redirect chain. If a URL is encountered again, it indicates a circular redirect. Asterisk configure request, settings equals settings.redirect handler equals custom handler, asterisk this applies the custom redirect handler to the request. How it works asterisk. 1. The should redirect async method checks if the maximum number of redirects has been exceeded. 2. It extracts the redirect URL from the location header of the iFlurl response. 3. It checks if the redirect URL is already in the underscore redirected URL set. If it is, a circular redirect is detected, and the method returns false to stop the redirect. 4. If the URL is not in the set, it's added, and the method returns true to allow the redirect to proceed. 5. The before redirect async method allows you to modify the request object, such as adding headers for authentication or authorization purposes. When to use asterisk this is the preferred approach when asterisk you suspect circular redirects are occurring. Asterisk you need more granular control over redirect behavior, example logging redirects, inspecting redirect URLs. Asterisk you need to apply custom criteria to determine if a redirect is part of a circular pattern. Asterisk you want to prevent a potential DOS attack by aggressively limiting redirects. 3. Using global Flurl settings, for app-wide configuration. Instead of configuring redirects on each individual request, you can configure them globally using Flurl http.configure. This is useful for setting default values for your entire application. Explanation asterisk. Asterisk Flurl http.configure asterisk this static method allows you to configure global Flurl settings. Asterisk settings.defaults.max redirects asterisk sets the default max redirects value for all Flurl client instances. Asterisk settings.defaults.redirect handler asterisk sets the default iRedirect handler for all Flurl client instances. When to use asterisk this is ideal when you want to apply the same redirect settings consistently across your entire application. It simplifies configuration and ensures that all requests are handled in a uniform way. 4. Handling temporary and permanent redirects separately asterisk asterisk. Sometimes, you might want to treat temporary redirects, 302, 307, differently from permanent redirects, 301, 308. For instance, you might want to cache the results of permanent redirects but not temporary ones. Your custom should redirect async method can examine the response status code to make this distinction. 5. Asynchronous considerations and cancellation asterisk asterisk. Asterisk cancellation token asterisk pay attention to the cancellation token parameter in the should redirect async and before redirect async methods. Use it to gracefully cancel the redirect process if necessary, especially in long-running operations. *async/await * ensure that your custom redirect handler methods are implemented correctly using async/await to avoid blocking the calling thread. 6. Debugging circular redirects. When you encounter redirect issues, effective debugging is essential. Here are some tips. *logging * add detailed logging to your custom redirect handler to track the redirect URLs, status codes, and any relevant information. This will help you understand the redirect path and identify the point where the loop occurs. *network tracing * use tools like Fiddler, Wireshark, or the browser's developer tools, Network tab, to capture the HTTP traffic and examine the redirect responses. *reproducible test cases * create minimal, reproducible test cases that demonstrate the circular redirect problem. This will make it easier to isolate the issue and verify your fixes. *simplify * temporarily disable parts of your code or reduce the number of redirects in your test cases to narrow down the source of the problem. Example of a more sophisticated circular redirect detection *. Key improvements in advanced version *. One-time-based circular detection. The code includes a _time window field that specifies a duration within which a repeated redirect is considered a circular redirect. This helps to avoid incorrectly flagging a valid redirect that happens to revisit the same URL after some time. 2. Concurrent dictionary for timestamps. The code uses a concurrent dictionary to store the timestamps when a URL is redirected. This ensures that the code is thread safe and can handle multiple concurrent requests without causing data corruption. 3. URI parsing error handling. There is a try-catch block when creating a URI object from the redirect URL. This handles potential URI format exception errors, preventing the code from crashing if the redirect URL is invalid. 4. Handling missing timestamp data * the code checks if the _URL timestamps dictionary contains the timestamp for a URL. If the timestamp is missing, it logs a message and proceeds with the redirect. This prevents the code from throwing an exception if the timestamp data is not available. In summary, handling circular redirects in Flurl requires a nuanced approach. Start with increasing the max redirects setting. If that's insufficient, implement a custom redirect handler to gain full control over the redirect process, including detecting circular patterns, logging, and potentially modifying the request. The key is to choose the right strategy based on the complexity of your redirect scenario and the level of control you need. Remember to thoroughly test your implementation to ensure that it handles redirects correctly and prevents infinite loops.